So we are in section 2.6, right? 2.6. So in the last video I gave you the brief introduction to the exact equation. So what was that? We say that a differential equation of this form, m times dx plus n times dy, where m and n are a function of x and y both. So this can be written this way too: mxy plus nxy dy over dx equals to 0 is exact if and only if the derivative of m with respect to y is equals to the derivative of n with respect to x. If they are equal, then this derivative is a partial derivative. Okay, partial derivative means when you find out the derivative with respect to y, then you take x, anything other than y as constant. Okay, when you are finding with respect to x, then anything other than x are the considered as constant. Okay, so if the partial derivative of m with respect to y is equals to the partial derivative of x with respect to n with respect to x, if they are equal, then we call exact. Now how do we solve the exact equation? So the idea of the exact equation is we should be able to find out a function psi so that the derivative of the psi with respect to x will be exactly same as this left hand side, so that you can write the left hand side with the derivative of psi form, and then when you integrate, then you can solve the equation right away. Okay, that's the idea. So to solve exact ODE, we need to find a function psi xy such that the derivative of the psi xy is the whole left hand side. Okay, whole left hand side. So if you can find a psi xy function in that way, then the left hand side can be written as derivative of psi xy, right? So you can write this as derivative of psi xy with respect to x equals to 0. Now when you integrate, you can find out that psi function right away. That is the idea. So what does that means then? So the derivative of psi xy with respect to x equals to, that means when you find out the derivative of this, then you will get psi x equals to m and then psi y equals to n. That's what you will get if you write them equal. Because how do you find out the derivative of a function, right? So if there is like, do you remember that in the I mean, you will see this in calc 3, okay, when you do the partial derivative. But if you don't know, then or if you have not seen it, then this is the formula. Okay, so suppose that y is a function of x. Okay, so y is a function of x, and suppose that, let's say, u is a function of y. See, y is a function of x and u is a function of, you can have u is a function of x and y, okay, y is function of x and u is function of x and y. So if you want to find out derivative of u with respect to x, so what you need to do is you need to do for each of those. Okay, so what you can do there is you can find out du over dx and then times dx over dx, which is 1, right? You need to do each for each of them, and then plus du over dy, because this y has x in it, because that is that, so times dy over dx. Okay, so basically this will give you du over dx, right? And then this is 1 plus du over dy times dy over dx. Okay, so another example I can give you here is, let us say that w is a function of u and v, and where u is a function of x and then v is a function of x, meaning that w is depending on u and v. Okay, where u is depending on x and v is depending on x. So if you want to find out dw over dx, you want to find out the derivative of w with respect to x, then what you need to do is, although there is no x explicitly here, okay, there are u and v, but u and v are depending on x. What you do is dw over du times du over dx. You need to go inside u and then find out the derivative of u with respect to x, and then plus dw over dv times dv over dx. That's the formula we use. Okay, so in our case, so look at this. So here what is happening is psi is function of x and y, where y is also function of x. It is like that. Okay, psi is function of x and y is function of x. If you want to find out the derivative of psi with respect to x, you need to go to x first, that is d psi over dx, right? This will be like d psi over dx times dx over dx, which is 1, right? And then plus d psi over dy times dy over dx, right? So what do you get then? So this will be 1. So you will get d psi over dx equals to the first one, because see, this is just, this one comes with the derivative, which is, this is comes with derivative. So if you write these two, if they are equal, then the m must be equals to d psi over dx, right? And then n must be equals to d psi over dy. So that's the concept that we did in the last video. Okay, guys? So what we want to do next is we want to do some examples that we need to test whether a particular function or the particular differential equation is exact or not, and then we will if it is exact, then we will try to find out the solution. Okay, guys, that's what we want to do. All right, so look at this example. Is the ODE, this x positive, y positive, exact? Let's see that. What is m? M is x ln y plus xy, right? What is n? N is y ln x plus xy. To check whether it is exact or not, what we do is you need to find out m sub y, meaning the partial derivative of m with respect to y. So what is m sub y? Is x is considered as a constant here, times 1 over y, right? And then plus, this will be just x, because we are finding with respect to y. So x is considered as a constant. Only the variable is y here. Similarly, what is n sub x? Because for the exactness, you need to have these two equal, right? So what is n sub x? N sub x will be y times 1 over x, because the derivative of natural log of x is 1 over x. And then plus, what do you get here? It is just y, right? So are they equal? So you got x over y plus x. And this one is y over x plus y. Do you think they are equal? No, right? So this is not exact. So how do you write that? Is not exact. So we are not trying to solve it. It is not exact. So we just say that it is not exact. We're done here, okay? Okay, this example is dy over dx equals to negative 4x plus 2y over 2x plus 3y. Is this exact? If not, then you will stop. If yes, we need to solve, okay? So let us do this solution. So let us first write down in that form or this form, okay? So you can write this as 2x plus 3y times dy, okay, equals to negative 4x plus 2y times dx. This is the differential form. So what you can do here is you can write negative 4x plus 2y dx. Oh, that is positive, right? Because if you bring that to the left side, that will be positive. So 4x plus 2y dx plus 2x plus 3y dy equals to 0, right? Now, what is m? M is a 4x plus 2y. What is n? N is 2x plus 3y. Now, to check whether it is exact or not, what we need to do here is basically find out m sub y, meaning the derivative of m, this thing, with respect to y. That is 2. What is n sub x? This is also 2. You see that? So, it is exact. It is exact. Okay, so to solve this or to find out the solution, what we do is we need to write, we need to find out a function such that psi of x equals to m. We need to find a function such that psi of x equals to m, right? What is m though? So m is 4x plus 2y, 4x plus 2y is the m, right? Now we need to find out, our goal is to find out the function psi. So how do I find out that? Is integrate with respect to x, okay? So if you integrate, what do you get? If you integrate on both sides like this with respect to x, right? What do you get on the left is psi xy is equals to, what is the integral of 4x? It will be 4x squared over 2, right? 4 times x squared over 2. And what is the integral of 2y? Because it is considered as a constant when you integrate with respect to x, okay? So it will be 2xy plus a constant, right? So that constant can be a function of y or a constant, right? Let me write down h of y there. Because if you find out the derivative of this with respect to x, then this will go to 0, right? So you can write a function of y as a constant there, okay, because we are doing with respect to x. All right, so now, so what I want to do is, my goal is to find out the value of psi function, right? So we need to find out the value of h. What will be the hy value, okay? So what I'm going to do here is, I wanted to look at this. What should be this? If it is, if the equation is exact, then to solve, we will use psi x equals to m. We use that already. Now we need to use psi y equals to n. So what I want to do here is, I want to find out the derivative of this with respect to y, psi sub y. You can write x comma y there, or you can just don't write. It is understood. Now we want to find out with respect to y, meaning all the other things, all the other things except y will be considered as constant. So this will be 0, plus the derivative of this with respect to y will be 2x, plus this will be h prime of y. You see that? So that is h prime of y. Now, what is the value of psi of y? Psi of y is n, right? What is n though? N is 2x plus 3y, right? So that will be 2x plus 3y. So we got 2x plus h prime of y is equals to 2x plus 3y. Subtract 2x. What do you get? H prime of y is equals to 3y, right? That's what you got. So what is hy then? We need to integrate again. So h of y equals to 3 over 2 y squared plus a constant c. Okay, guys. So what can we write for the psi xy then? So see, we got the expression for psi xy is like this, right? Now what we want to do is, hence psi xy is equals to 2x squared, because 4x squared over 2 is 2x squared, plus 2xy plus 3 half y squared plus c. That's the value of psi xy. Now, what is the solution then? Because we see that now if you take this psi xy equals to that thing, then you can then you can write the whole left hand side as the derivative of this psi xy. Because see, you see that? What is the derivative of this with respect to x? Will be 4x, right? Plus, so it will be like product rule, right? So if you do with respect to x, then you will get 2y, 4x plus 2y. Did you see that? 4x plus 2y there. And then plus, it will be, when you do with respect to y, then this will be the product rule, right? So you will get 2x dy over dx plus 3 half times 2 will be 3y, and then dy over dx. That's what you will get, 2x plus 3y, right? So this is the required function that we got now. So the left hand side can be written as the derivative of the psi xy, right? So the derivative of dx psi xy equals to 0, you can write. So if you integrate, then what do you get? You will get psi xy equals to a constant k is the final answer. Okay, what is the final answer then? Just plug in the value of that. 2x squared plus 2xy plus 3 half y squared plus c equals to k, but you can bring that c and then combine with the k, then you will get, let's say, k1 or a small k. Okay, so you can think that this has k1 and this will be k. So this is the final answer. Okay, guys. So this is how you solve an exact equation. Okay. So I am going to do one more example on this. So another example is, find the value of b so that this equation xy squared plus bx squared y plus x plus y x times x squared times dy over dx, right? That is y prime equals 0 is exact. We need to first find out the value of b and then also solve the ODE. That's what you want to do here. Okay, guys. So what is m here? Let me write down the solution. So to be exact, we need m sub y is equals to n sub x, right? You need to have that. So here m equals to xy squared plus bx squared y. This is m. And what is m sub y? Is 2xy plus you get bx squared, right? And also Also, what is n? N is x cubed plus yx squared. Did you see that? Why? Because this is x plus y times x squared, right? So that is the n. This total is the n thing, right? So if you distribute this, you'll get x cubed plus yx squared. So what is n sub x? That will be 3x squared plus 2xy. But to be exact ODE, what do we need? We need m sub y equals to n sub x, right? Let's plug in those values. 2xy plus bx squared equals to, what do you get? You get 3x squared plus 2xy. So if you solve this, what do you get? You subtract this with that will cancel out, right? When you subtract and then divide by x squared, that will cancel out too. So you get b equals to 3. We get the value of b is 3. So b equals to 3 will make this ODE exact, right? Now how do I solve this? To solve this we use, because we need to find out a function psi, so that psi sub x equals to m, and then psi sub y equals to n. That's what we use to solve this, right? So what is psi sub x? Then psi sub x equals to m is xy squared plus 3x squared y. You see that? Because I use that value of b as 3. Okay. Now integrate this with respect to x. What do you get? If you integrate with respect to x, then you get psi is equals to, so what is the integral of x? It will be x squared y squared over 2, because the y squared is time, so it is like a constant, right? Now how about that one? So what is the integral of 3x squared? It is x cubed, right? Plus x cubed times y plus this is h of y. You see that? Because when you integrate, you need a constant, but since psi is a function of x and y and we are integrating with respect to x, so any function of y can be considered as a constant there. Okay, now we need to use the second this identity. So what you do is find out the derivative of this with respect to y. What do you get? You get psi of y is equals to, let's find out that. You get 2 and then y x squared divided by 2 will be yx squared, right? And then plus the derivative of this with respect to y will be x cubed. You see that? And then plus you get h prime of y. All right. So now we need to find out the value of h prime of y, but how do I do that? But this psi of y is equals to what? N. What is our n? N is x cubed plus yx squared. So x cubed plus yx squared. See, when you write them equal, when you write these two things equal, then x cubed and x cubed will cancel out, yx squared and yx squared will cancel out. What do you get? You get h prime of y. So h prime of y is equals to 0. So what is hy? You integrate this with respect to y. You get that implies h of y is equals to a constant k, right? So what do we do? Hence psi xy equals to x squared y squared over 2. You see that? Plus x cubed y plus a constant. That is the value of psi. Now what is the final answer? Is and thus the answer is this psi xy equals to a constant c. So you write x squared y squared over 2 plus x cubed y plus k equals to a constant c. Let's say c1, and then you subtract that because this is only constant on the left hand side, right here, and you can move this to the right side. You will get c1 minus k. Let us consider that is a c. Okay, so you can write x squared y squared over 2 plus x cubed y equals to c. So this is the final answer for this. Okay guys, so these examples show you if a differential equation, ordinary differential equation is given, and then you can check whether it is an exact equation or not. If it is exact equation, then you can solve by this technique. Okay, all right guys, so as I mentioned earlier, not all differential equations can be solved by hand, okay, explicitly. Okay, so some of them can be solved, but On those that can be solved, there are various techniques you need to use, okay, and they may be very hard to do by hand too. So these are some of the techniques we are learning, okay. There are some more, but so far how many techniques did we learn? We learned the separation of variable, we learned the linear method, right, and the third one, this one is the exact method, right, so the exact ODEs. All right, guys.